And today I will give you an introduction of what is called engineering projects in Taiwan. In Laird. Generally, core engineering project is always for those products and the design are not on the shelf. So we need to work with customers R&D and the engineer from very beginning start to finish to create a quick and efficiency solutions. Sometimes the core engineering design is not just for metal parts only. We could integrate other material like absorbers or thermal material together to solve a customer's particular design challenge, including from EMI or thermal perspective. And also, by our experience, manufacturability and some critical final element analysis capability, we could optimize the design for customer for your designs. So, and here are several photos show the products we had done before with customer in this kind of core engineering projects. And here is a high-level core engineering benefit. So this is the high-level view of core engineering benefit by our metal technology. Just like, for example, here in consumer products like the mobile phone, watch, tablet, pad, or even other wearable device. This product design is going to be thinner and thinner. So their pain point would be how to utilize the limited space well and do the best on the zero gap design. So we could provide some special technology in our Laird metals, like low high BLS for them, and also with some unique feature design like the rigid corner to increase the product stress. So with our high precision stamping tool and 100% coplanar control, we could provide several benefits. We could provide several benefits to customers, like enable a smaller and thinner electronic device and easy assembly ability and a good production yield from customers' perspective. And regarding our design expertise, we have very good custom design knowledge, and this could optimize the mechanical structure and the EMI solution to address the manufacturability. And regarding the deep drawn technology, we have very strong tooling design team and some simulation software, so we could compress the shape and form optimizations. And the integration of absorbers and metals, we could optimize the shielding performance and improve the manufacturing efficiency from customer perspective too. Not just provide the shielding performance, but also integrate the absorber performance to reduce the EMI noise. And here we have the selective printing, and this selective printing could reduce the expensive metal usage like gold, and also with this selective printing, we still could maintain the part with the required function like conductivity. And regarding the multiple material joining, we could use the laser welding process technology to join the two different metal coils together. So we could reduce the part numbers and improve the manufacturing assembly well. So not only the EMI function methods, we are also able to design and manufacture structure methods for customers. And the benefit for customer is reduce the supplier base. They could use one supplier to provide EMI solution and also mechanical structure solutions together. And now here are what we can do in co-engineering projects. Like the DFN, design for manufacture, we could do, we will review every metal design to make them be feasible to run the mass production. And we could optimize the customer design. Also, we have a final element analysis capability, including the resilience force and permanent deformation simulation. Also, we have the EMI simulation and the deep joint simulation capability. All these capability are the in-house capability. So the left top one is the resilience force simulation when the metal part is during the compression. From this chart photo, you could see the finger is keep pushing, and we could do the compression force simulation result based on different compression ratio. So this one is generally used in the finger stop application because finger stop needs to be compressed. And left down one is the deep joint feature simulation. We could know where is the stress point, just like here. The darker one is the stress point, so it could be cracked easily during the stamping process. So we could use this simulation result to optimize or design our tool layout to prevent the stamping part deform. And the right hand side one is the shading effectiveness simulation. You could see the chart, the photo here by different color, different dark or light. It shows the shading effectiveness performance. So with this result, we could know if the parts, the BLS part, shading parts design could be performed well or not in particular frequency range. So if the shading performance is not meet our expectation by this result, we could modify the metal part design quickly and easily, and then make the final tool kick off. So next, I will go through several core engineering examples for your reference. Here is the first one example I want to share with you, and this example is that we work with an automotive customer in China. The application is iBox for IOV, and this customer is not very good at shading plus design, so they just provide us their PCB layout and tell us their soldering area. And based on this information, including what kind of material and what the frequency they want to share. So we do the two-piece BLS plus design, totally 5 sets, one in top and another 4 in bottom. So the benefit for this customer is they could have a reliable EMI solution from Laird from us. So even they provide the PCB layout in very short time, we also able to do the total design, finalize the design within a week. So the customer is very happy with our support for this shading design. And this one is the sorry, is the telecom 5G product. Originally, they used the die casting metal parts to do the shading function, but they want to reduce the product weight because the die casting part is too heavy, and also they want to reduce the BOM cost because the die casting part is always expensive than general metal stamping part. So they asked Laird to evaluate the metal stamping technology to replace their current die casting solution. So we got a PCB layout and also get their current die casting 3D models. Then we do some simulation, including the final element analysis and also the shading effectiveness simulation by 3 different design options, design structures. So we successfully use the stamping parts to replace the die casting parts. Not only not only reduce the part weight, also provide them the similar shading effectiveness performance as die casting part. So this customer is very happy at the BOM cost saving and also have the same performance as die casting parts. And this one is the ADAS application in automotive. And this model is actually had be the new generation models. We had worked with this customer for 2 models already, and this one is the latest one. You could, in this design, you could see there's an emboss on the cover parts. So we did the deep drawn simulation to optimize the emboss feature. You could see from here, you could see we designed 3 drawn step in tool to form this emboss feature. So this 3 step design in tool was based on our deep drawn simulation result. So no matter from customer or Laird, we reduce the prototype investment cost and the tool trial run time, and then let this part run into mass production in very short time. And by general exercise, we some stamping provider will do the tool try run several times try run to make the invoice perfect. So we do the design and do the simulation and then design the tool and make the tool. So reduce the time and the cost. And this one is also for 5G AAU applications. This is the linear copper finger. This finger needs to be inserted into a cylindrical connector, and the fingers need to be conducted the cylinder side surface very well without any conflict. So before we actually make the physical parts, we do the compression simulation first, and then by this result, we did several times product design modification to optimize the compression force and the finger movement during the insertion. So in this case, we also reduce customers' effort and NPI cost for prototype development to evaluate. So customer could use our simulation result to evaluate their final product's performance very quick and easily. And this is a typical integrated solution of Laird product. It has a two-piece BLS frame and cover, and there's the thermal pad on the cover. Inside the cover, here is the thermal pad, and outside the cover, there's another thermal pad. So, and assembly with aluminum heatsink here. So, in this design, it has a good EMI shading performance by BLS cover and BLS frame, and also the good thermal management by thermal pad and heatsink. So provide customer a total solution from our core engineering capability and also from our Laird wide product portfolio. So regarding the core engineering support, you could get the support from this email address or the phone numbers in your region from EU or Great China or even the North America. So you could get a support from this contact information for the core engineering support. And now I will finish my core engineering session here, and then Manuel do the prototyping introduction to you guys. Okay, thank you. Manuel.
Yes, hello. Thanks, Kevin. Hello, good morning, good afternoon, good evening, depending on where you are. Kevin was presenting a lot of good solutions to give our customers the best possible support. But to make it perfect, one piece is missing: prototypes. So simulations, tests, and other feasibility checks offer a certain degree of confidence that the product could be the right one to solve the problem. But at the end, they need samples, and that in most cases as fast as possible. Kevin, are you moving around? So in the following slides, I want to bring some important points up to your attention to promise a smooth and reliable process to deliver prototypes on time. Kevin, can you move to the next slide? Thank you. As a global leader and partner, we want to ensure that our customers get local support. So having tight communication in the same time zone and short transportation routes is saving customers time and money. Another advantage is every region has its own focus on other market segments with different requirements. So based on that, they are learning from each other and share best practice. Another point is, since all the sites are a little bit differently equipped, we can support each other well in terms of raw material availability or needed capability, as well as exchange of experience. Here on the slide, you can see the main manufacturing sites. What we have not shown here yet is Vietnam. They are also a manufacturing site and also starting making prototypes. So this slide has to be a little bit updated in the next time. Next slide. So the most competitive advantage is speed. You may agree or don't agree. I know it's not only speed, but it's a very important element to keep us in the race. If we can confirm customers' requested delivery dates, he is able to keep his schedule. So our commitment is quite simple. If we give our customers the right support, as listed here on the left-hand side, for example, interactive response, modeling, simulations, all this kind of stuff, what Kevin already presented, customer would get all these benefits which are listed on the right-hand side and recognize Laird as a valuable partner. Next slide is modeling and simulation. So that is something you probably have to start with in most cases. We added some important points you should include in your discussions with customer beforehand. So in this case, I hope I picked up a good example of a quite complex connector shield. This part is pre-bended and you probably cannot really see it, but on the side there are locking dimples because this shield is already closed. But it needs locking dimples so that the worker on the assembly line can put the shield around the connector and use the locking features to close the shield. And to ensure that the locking features are really fixed, the customer made a kind of vibration analysis and tested the connector to avoid that the connector falls off or get lost. So before we finalize the design prototypes, we must check not only the feasibility, but also to think about the best manufacturing process and a hard tool concept. On top of that, another important point could be the life cycle, for example, the compression force. You see here on the part that the part has some fingers on top. So maybe you have to think about to pick the right material. Cold rolled steel, for example, is the cheapest material, but has no spring back. So I was talking about the life cycle and compression force of the fingers. So did they pick the right one? Cold rolled steel is supposed the cheapest version, but maybe has no spring back, for example. So what does the customer need? Do they need a permanent contact point? Or does the contact fingers have to withstand 10,000 cycle times? Another point is Laird can also take the lead in coordination with the customer. Another point is finite element analysis. So the finite element analysis is the most widely used method for solving problems of engineering models. For example, here the typical problem areas are parts with drawn features where you want to understand how the material flows. So you may have to use thicker material to avoid cracks or have to make dimensional changes. Another point which we have to consider is we have an EMC lab, so we can also offer the customer that we can do some shielding effectiveness testing. Okay, next slide, Kevin. So here's another example. Maybe you remember in the previous slides I mentioned a lead time of 5 days for quite simple parts. On the other hand, this part was a huge challenge, but finally we found a good way to make it manufacturable. And the customer was not requesting 5 days. So even 4 weeks for such a very complex, sophisticated part can be a reasonable time for the customer. So what we have done here is we run several simulations. Then we found a way to cut around the pins to meet the tight tolerances. We had to build a soft tool, and finally the outcome you can see on the right-hand upper corner. And that within 4 weeks. What I mean with that is what I already said, 4 weeks can be a good prototype lead time because others offered 8 weeks, for example. Next slide. Moving forward to our standard material. To keep the timeline or the lead time quite short, we have to think about to use our standard material. And to shorten the lead time as much as possible would be perfect to pick one of our standard materials listed here in the table. So you have here, starting from the left side, beryllium copper, nickel silver, stainless steel, and cold rolled steel, which are the most used one in the application. There is still a demand for phosphor bronze, which I did mention before, but with low demand compared to the other materials. So from cost point of view, beryllium copper is the most expensive material and cold rolled steel the cheapest one. So here you can see some pictures about prototypes and more detailed information about tolerances as well as lead time. If you need, for example, just simple V-bending tools, for example, when you talk about a simple board level shield with just folded sideboards, the lead time is 50% less compared to soft tool parts. But the more, let's say, complicated the parts will be, the longer the lead time, because you have to build more tools, or maybe you have to end up in a soft tool, which takes up to 14 days, plus 1 or 2 days for the prototypes and testing. Here to mention is the flatness for prototypes, which is much higher compared to the hard tools. So we have really to consider that the customer could have an issue with the solderability, which has to be clarified before making prototypes. Of course, these are just guidelines, and maybe even with soft tools we are able to go down to 0.10 flatness, but this is just a bandwidth to explain the customer that a soft tool is not a hard tool. So Laird capabilities process related. So how do we support each other? An SLA equipment to support soft tool build, spare parts, or printing counterpart to simulate assembly processes. On the left side, you see the SLA machine. On the right side, it's a kind of soft tool. Laser equipment. The laser equipment is very important to quickly cut blanks or to be used for spot welding of different materials. And the V-bending tools, what already explained before, are used for the simple bendings, which are easily made in a few hours and shorten the lead time a lot for very simple products. Another point is Laird's capability testing. Very important to mention here is that we have 2 labs to test the cleanliness of stamped metal parts for metallic particles, as well as for non-metal parts. One lab is in Liberec and another one in Shenzhen. Renosa is following soon. So especially in the automotive and medical applications, the cleanliness requirements are getting more and more strict. Shenzhen has an EMC test chamber to offer service to measure shielding effectiveness. That is the next one. And the last one is the ORS lab to test and ensure that our products are free of any forbidden, restricted, or hazardous substances. So in the next slide is showing a lot of prototypes, for a wide range of different applications. Large and small BLS connector gaskets, many grounding and battery contacts. It should give you just an overview and a clear picture of what we are able to do with soft tools or with simple V-bending tools. And the last slide. You may don't believe it, but it's always good to let them know we are an IATF certified company in all regions. A lot of our competitors, especially in metals, are still just ISO 9003 certified, which could be an advantage for Laird at a later stage when quality steps in. So in some cases, we should talk about this because I think what I have seen so far, it's very difficult to find our webpage what kind of certificates we already have. Okay, I think, Kevin, yeah, this was the last slide. Thank you for that.